This meeting is being recorded.
Welcome, and today we're going to be speaking a little bit about sulfur for the next 40 minutes. We're going to be speaking about what sulfur is, how we get it, why we use it. Then we're going to be speaking about the preparation of hydrogen sulfide, sulfur dioxide, and we're going to finish off by speaking about the preparation of sulfuric acid. If you have any questions, please don't hesitate to ask. I know it's an online lesson, but remember, in class, you would be asking anytime you have a question. So here, you can stop me and ask, okay? We're gonna start this off by seeing a video about the mining of sulfur.
He's a sulfur miner, and he works for $8 a day, carrying up 100 kilos of sulfur to the top of a volcano. These hard-working men struggle with back-breaking pressure on their shoulders as they climb the uneven, rocky surface. The weight is so heavy that over the years it gives them nerve damage in their shoulders and spine, and they can no longer feel their collarbones. I wanted to try this for myself to put it in perspective, what these men are putting their bodies through as they're breathing in the sulfuric gas. I can't even get off the ground. Oh man. How does it feel? That's 80, maybe 90, a few more, maybe more. But wow, I could not do that up here. Not a chance. I couldn't even make it out of this ditch. That's insane. So right now, we're in one of those toxic clouds. So the sulfur gas is coming in. It's burning my eyes. They're gonna start watering soon. And we have to have these masks. I feel so lucky. Some miners, they hike up this for 30 years with no masks. They get really bad respiratory issues, and unfortunately, a lot of them in their 40s and 50s, they actually pass away because they've done so much respiratory damage from this toxic gas.
Hello, my name is Coco. I was a miner before.
When you wake up in the morning, do you cough?
Yeah.
Do you cough every day?
Yeah, every day.
So Udi, why would anyone want to work in such a dangerous environment?
Because they don't have education, so that's why they're working to be miner here. For money, for the family. The miner here don't care to the body, also for health. They have to get money for family, buy food.
So Udi, what is the sulfur used for?
For whitening sugar and cosmetic, also for medicine for skin. This is good for the skin. Sometimes it's my father sleep in here until 1 week not to go home. And sometimes he's very tired and then sleep on the way on the road like that with the carrying sulfur.
These miners sacrifice their bodies, lungs, and time away from their families, all for $8 per load per day. I would like to increase the awareness of this place to get more people interested in helping these miners. I was just talking to Udi, and it looks like there is a silver lining for these really hardworking men. It looks like social media awareness is helping bring more attention to the area. Please share this video. I want to get the word out there to get more people coming here so people like Udi and the miners can have more protective gear and really have a much better quality of life.
So, sulfur is actually a very important element, okay? Do you have any idea why we use sulfur? Do you have any idea why we use sulfur?
Fireworks.
Fireworks, okay, a little bit. We'll speak a little bit. Why? Anywhere else? Why do we use sulfur? Any other ideas? They did mention a few.
Whitening sugar.
Whitening of sugar. So sulfur is used in preparation of rubber. So we won't have tires without sulfur. Bleaching paper, detergent, pesticides for the skin. But the biggest use is in the preparation of sulfuric acid. And sulfuric acid is one of the most important acids that we use in chemistry. Not just with respect to the preparation of the acid itself, but its salts are also very important. So now we're going to be speaking a little bit about sulfur, not just, so we've seen how much these people struggle to make sulfur, but what is sulfur? And sulfur has allotropes. In fact, sulfur has 2 allotropes. Anyone knows what an allotrope is? So allotrope we've mentioned up till now in both oxygen, and we've also mentioned the word allotropes in carbon. So what is an allotrope? Do you remember what allotropes are?
The same element without change.
So it's the same element, but it will have a different structure. So in this case, for example, sulfur can be either rhombic and monoclinic. And for sulfur here, this change happens with a temperature at 96 degrees. So here, sulfur, rhombic and monoclinic do not exist at the same temperature. But if you had something like carbon, where you have graphite and diamond, okay, or oxygen, which is where you have O2 and O3 ozone, they can exist at the same temperature. Okay, in fact, for carbon and oxygen, they do even have some different physical and chemical properties. For sulfur, okay, they are going to be at different temperatures, so you can't actually have them at the same time together. But for the other allotropes that we've mentioned, okay, so the allotropes of oxygen and the allotropes of carbon, you would be able to. But for sulfur, the 2 allotropes, they will change from one to the other, okay? And this is possible because sulfur is really not just one atom. Sulfur is an S8 ring, like we write oxygen O2, okay? Sulfur is S8. This is not something important for GCSE, but it's something that is cool to know. This is something that will help you understand how you can have different arrangements. Because when you have one sulfur atom, of course, that's going to be on its own. But when you have S8, then you can realize that you can have different arrangements. So for oxygen, for example, the allotropes would be oxygen, O2, and O3, and allotropes of carbon, these are the diamond and graphite. Okay, so please do note that for sulfur, you have a different structural formula, different structural form that happens to change at a different temperature. So you have above 96 degrees, you have the monoclinic, below you have the rhombic. Okay, then we're going to be speaking about the preparation of H2S. H2S is an insoluble gas. Now, what do we mean by an insoluble gas? Any idea? What do we mean by the term an insoluble gas? Who can tell me?
It doesn't dissolve in water.
It does not dissolve in water. Does not dissolve in water. So in fact, to prepare it, we will require 2 soluble salts. So to prepare an insoluble gas, we will require to mix the 2 soluble compounds, because we can have soluble compound plus another soluble compound to give something insoluble. Okay, so we need to get something to give us H plus and something to give us S2 minus. Any ideas what compounds could give us a proton, an H plus, and the sulfide and S2 minus when dissolved in water? So for the solubility table, what would give us an H plus and what would give us an S2 minus? Any idea? Remember, the first rule states that we've done for the solubility table. All sodium, potassium, and ammonium salts, okay, are soluble. So what would that mean for here? Which sulfide salts would be soluble? Which sulfide salts would be soluble?
Iodide and potassium.
So potassium sulfide. Iodide is an anion, like the sulfide itself. So iodide would definitely not be usable for the S2 minus. So for the acid, you can use the HI, hydrogen iodide. Hydrogen iodide is a bit strong as an acid. So normally, instead of the hydrogen iodide, we would use hydrogen chloride, HCl. So here we can have HCl plus Na2S to give H2S plus NaCl. And for the balancing, we will require 2 HCls and 2 NaCls. So what I would like out of you, take some time to find out to give me the ionic equation. Okay, so if you would like to see the answer, stop the video here and then see the answer afterward. So for the ionic equations, what we need to do is we need to write the states. So this is aqueous, a gas, and aqueous. And then we're going to write the ions for only those items that are aqueous or that are changing. So here you have H plus, Cl minus, you have 2 of each. We have 2 Na plus and S2 minus to give H2S, and it is a gas and not aqueous, we don't write it, plus 2 Na plus and 2 Cl minus. And here we will cancel those items that are present on both sides. So 2 Cl minus, it's on both sides. Same thing as the 2 Na plus, they're on both sides. And then for the ionic equation, we'll write whatever is left. So you will have 2H plus S2 minus to give H2S. And to finish it off, we will actually write the state symbols. Okay? So any acid with any S2 minus will give us H2S. And this is important when we are preparing these compounds, because what this is going to tell you is that any acid with any S2 minus, with any sulfide, as long as they are all soluble, will give you H2S. Okay? So then we can prepare SO2. Then we can prepare SO2. Now, SO2 you have never done, but you have done the preparation of CO2. Okay, do you remember the preparation of CO2? Okay, this is a reaction that is probably very common. This is a reaction that is probably very common when you are working with. This is a reaction that is common with acids and carbonates. So do you remember how to prepare CO2? Any idea? So you've done this in your previous chapter, carbon, but you've also done this in the chapter of acids and bases. Okay, so when we're doing these, now we're going to be doing a number of different groups. Okay, sulfur, nitrogen, halogens. We're going to try and refer back to what you've already covered. So any idea how to prepare carbon dioxide? idly.
CaCO3.
Mm-hmm.
2HCl changes into CaCO plus CO plus CO.
So here we have a carbonate plus an acid to give salt plus water plus carbon dioxide. And this is a preparation of CO2. Now the same thing can be used to prepare SO2. But instead of using a carbonate, okay, instead of using a carbonate, you can have a sulfate. Sorry, a sulfite. Okay, we're gonna say the sulfate 4, but for you, for GCSE, it's still with the sulfite. Okay, so here you could use calcium sulfite plus 2HCl to give you calcium chloride plus water plus sulfur dioxide. So I'm gonna give you the reagents. Okay, and then so calcium sulfite plus hydrochloric acid. So what I want from you is to give me the products, okay, and to write the full equation. Again, you can stop the video here and you can find the answer afterwards.
This is being recorded.
So the product of this reaction, okay, will be calcium sulfite plus 2HCl, and the balancing is important to give calcium chloride plus H2O plus SO2. Now, SO2, okay, SO2 is a reducing agent. Min jaffi għajli għajza taf tgħidli what is a reducing agent?
It is oxidized while reacting with is reduced.
So a reducing agent will help something else to be reduced, while it itself is going to be oxidized. And this is in fact the test for SO2. Okay? You can use this as a test for SO2. Why? Because SO2, sulfur dioxide, will react with dichromate, so potassium dichromate, okay, do you remember the color of potassium dichromate? Orange? What color ħajmur Luke? Green. Okay? Now, there are a number of ways that we can do it. We can either pass the gas through a solution of potassium dichromate, or else we can use some moist paper moist in potassium dichromate solution. I'm going to show you a video of this test, okay? And you can see how this color is going to happen. So first, they're going to generate the sulfur dioxide, and then they will test it through potassium dichromate. So they are preparing for the potassium dichromate solution, okay? It does require a bit of acid for the reaction to work. Then they're gonna prepare the sodium sulfite solution, okay? And they're gonna add some acid. Once they add the acid, they are going to heat it up, because this reaction, unlike the carbonate, it's not gonna be very, very quick. Okay? Unlike the carbonate would immediately effervesce. The carbonate would immediately get, you can see the bubbles. So here you would need to hit. Okay? So the reaction starts, and they're gonna add and put the gas through the dichromate solution. You can see the bubbles forming, the bubbles in the dichromate solution. And the dichromate solution will then turn from orange to green. And that will show you that you have the presence of sulfur dioxide. Okay? So this is the test for sulfur dioxide. Okay? It reduces Cr2O7 minus to SO2. It reduces Cr2O7 minus from an orange compound to a green compound. Okay? Then, to close off this lesson today, we're going to be speaking about the preparation of H2SO4. H2SO4 is sulfuric acid. Okay? So, to make it, we use the contact process. Okay? So, to make sulfuric acid, we use the contact process. And the contact process, pretty much, is a very important process because we're producing H2SO4, which is commercially and a very important raw material. As we said, sulfur is mainly used to prepare sulfuric acid. Okay? Sulfuric acid is prepared as one of the biggest and mostly prepared compounds in the whole world. And it's used in fertilizers, in paints, pigments, detergents, car batteries, laboratory acids, and even in the use and in the preparation of explosives. Okay? And to make H2SO4, we need three items. We need water, air, and sulfur. Okay? Water, air, and sulfur. So the first step would be to get sulfur dioxide. Now, sulfur dioxide, and for these steps, I'm just giving you a set of reactions, okay? We're going to be speaking about these reactions further on during the next lesson. But for the first step, preparation of sulfur dioxide. So we can either burn sulfur directly, or else we can burn certain sulfides like zinc sulfide to get sulfur dioxide. And on burning sulfur with oxygen, we only get sulfur dioxide. Okay? If you have the zinc sulfide, remember, you will then get the zinc oxide. So ZnO. But as an oxide of sulfur, we only get one, SO2. Then, this SO2 can then react in the contact process, okay, to form SO3. But this reaction requires a catalyst. It will require V2O5 as a catalyst, okay? And we'll be speaking about the catalyst a little bit later on. But SO2 can give SO3 by the reaction of oxygen. Okay? Then SO3 is not reacted with water to form H2SO4, but rather it is reacted with more H2SO4 to form a compound called H2S2O7. And this is called oleum. And this is done because the reaction of SO2 with water is too exothermic. Okay? It's too exothermic. And not just too exothermic, it's also possible that it will form mist in the air that would be acidic. In fact, this is something similar to the formation of acid rain. So you're forming a very strong acid that can form mist in the air, okay? And it releases a lot of heat. So it actually gets the temperature to be very hot, okay? Because exothermic you might not have done yet. Exothermic is something we'll be doing in a chapter in the future, okay? So we'll be doing that in 4 or 5. Then you will add water to the oleum, okay? So the oleum will add water and you'll get 2 sulfuric acids. And from this, then you will get the sulfuric acid to any concentration that you might require. Now, here, you have a reaction of SO2 plus oxygen to give to SO3. So we require a catalyst, we require temperature, we require pressure. So catalysts, you might have used them in biology, okay? In chemistry, again, we're going to be speaking about catalysts a little bit more detail next year, but the catalyst is something that makes the reaction go faster, okay? So the catalyst for this reaction will be V2O5. The temperature for this reaction is going to be 450 degrees Celsius. We need the high temperatures to make the reaction go faster. And the pressure is 1 to 2 atmospheres. Now, pressure is important because pressure puts everything closer together where they can react. But the problem with pressure is that if you're going to have too high pressure, your apparatus must withhold that pressure. Your apparatus must be strong enough to withhold that pressure. And therefore, that would be a big expense. Therefore, most of the time, you will end up, keeping the pressures low. So let's go back and revise a little bit what we've done. So today we've spoken about sulfurs, and its allotropes, the preparation of H2S gas through two soluble compounds, okay? And it's important that we use two soluble compounds, okay? Because otherwise you will not be able to react them. Then we can also prepare SO2 in a similar reaction to what we used for the preparation of CO2. So we'll use a sulfite plus an acid. And then we spoke a little bit about the contact process. Now the contact process generates H2SO4. And we will be using H2SO4 in our next lesson. Okay? We will be using H2SO4 in our next lesson. And this will be used and we're going to be discussing the uses of H2SO4. And in fact, as part of your work for the next lesson, I would like you to look out these three words: dehydrating agent, hygroscopic, and oxidizing agent. Okay, so look those three words up and we'll be able to then continue from there. These three are all uses for sulfuric acid. Okay, thank you for your attention and I'll see you in the next lesson.